In our last episode, we took a look at implementing error handling in our state machine. And we asked a question at the end. If, for instance, I'm going to notify the user of whether a test passed, how does the notify VI know which test passed? And maybe values for the test, if the tests occur in other states. In other words, how do we get data between states? Within a state, it's pretty easy. We just pass the data to whatever handles it. But getting it from this state over to this state will require passing that data between loop iterations. Are your ears perking up? Because that's what a shift register is for. And that's what we're going to use. In this case, let's say I want to pass the data regarding the basic test from this state to the notify state. Well, I'll right click and create a shift register. Now what should I put in here? Well, this passed is a Boolean. So I could go and wire this Boolean into here. But then, what about the data for the advanced test? I can't use the same shift register because that'll be a different value. So I'd have to create another one. And then what if I also wanted the actual values for the test? Maybe some voltage values. Maybe for both tests. Well, then I have 4 different shift registers sitting here and pulling them off. And as you can imagine, as my application scales, I'd have a bunch of these. That's inconvenient. So what I really want is one shift register that holds all of those. And so we'll keep them in a cluster. We'll go back here, get rid of this, and instead, the data is going to more closely reflect what's in here. Now right here, we've kept the data pretty simple, numeric and Boolean. And we haven't even been terribly consistent about the labels. So let's change that. What we really want is an instance of a type definition in all cases. So I'll right click on the border and make this a type def. And open up the type def. Save it, keep the same prefix, and choose data. Let's make this a little prettier. Expand this a bit. Let's say the pieces of data we want are this. 4 simple pieces. The voltage for each test, and then whether that test passed or failed. So we'll call this basic voltage. And this basic passed. A line across the top, and make a copy. Control and Shift keeps in the same axis, and we say advanced voltage and advanced passed. Save that. And we'll look at the order of the controls, 0, 1, 2, 3. That looks good to me. So now this is an instance of the type def, and it got a little bigger. So we'll move it over a bit here. Rearrange some things. This also should be an instance of the type def. We don't want to make a new one, of course. We're just going to right click on it and replace it with the one we just made. That way it's still connected up. It's still in the block diagram. Much easier. Pull this over here. Line these up quickly. Same here. Gorgeous. Wait, not yet. Gorgeous. Now. Okay. So I'll close that out. This now is an instance of that type def. And of course, we want it going into here. There we go. And now this would be an instance of the type def too. So I can create a constant at the beginning of runtime in order to reinitialize the values in that cluster. Very nice. I can even put a label here. It's good programming practice. We'll just change it to data. And make it a little smaller. We don't need to see all of it. And now any other cases that need to access that, we'll just pull it from there. Now I'll need to go obviously to the advanced and do the same thing as I did before. I'd pretty it up, but in light of time, that's good enough. In we go, and out. And finally the notify state. Same thing. Obviously we still have this hollow tunnel, so we'll have to decide what to do in the other cases, like initialize, idle. Well, in idle we don't have to worry, because we're not changing that data or even calling it anywhere. So I'll just pass it directly through. So it's an initialize or error shutdown. Both of these use the untyped def data. So I won't make you sit through that. I'll go ahead and change that right now. Okay, all done. All of these now have the updated type defs. So I'll wire them in and out in all cases. Solid tunnel here means we have all cases taken care of.